National Electrical Code, or NEC, does indeed require the use of flexible conduit for connecting generators and automatic transfer switches, mirroring the requirements often applied to motor installations. This requirement stems from several key considerations, primarily focusing on safety, vibration dampening, and ease of maintenance. When dealing with generators and automatic transfer switches, it's crucial to understand the specific sections of the NEC that govern these installations to ensure full compliance. These sections provide detailed guidelines on the types of flexible conduit permitted, grounding requirements, and proper installation methods. Flexible conduit, often referred to as flex, offers a degree of mechanical protection to the electrical conductors while also allowing for movement and vibration without causing stress on the connections. This is particularly important for generators, which inherently produce vibration during operation. The constant vibration can loosen rigid connections over time, leading to potential electrical faults, overheating, or even fire hazards. Therefore, using flexible conduit mitigates these risks by absorbing the vibrations and preventing them from being transmitted to the wiring and connection points. There are several types of flexible conduit commonly used in electrical installations, each with its own characteristics and applications. Firstly, we have flexible metal conduit, or FMC, is a helically wound, interlocked metal conduit that provides a degree of flexibility and protection. It is commonly used in dry locations for connecting equipment and appliances. FMC is relatively inexpensive and easy to install, making it a popular choice for many applications. Secondly, liquid-type flexible metal conduit, or LFMC, is similar to FMC but has an added liquid-tight jacket that makes it suitable for wet locations. The jacket prevents water, oil, and other liquids from entering the conduit, protecting the conductors inside. LFMC is commonly used in outdoor applications, such as connecting air conditioning units or other equipment exposed to the elements. Thirdly, electrical metallic tubing, or IMT, although not flexible, is sometimes used in conjunction with short sections of flexible conduit to provide a combination of rigidity and flexibility. EMT is a thin-walled steel conduit that is lightweight and easy to bend. It is typically used in dry locations where physical protection is not a major concern. In situations where movement or vibration is expected, a short length of flexible conduit can be used to connect the EMT to the equipment. Fourthly, flexible metallic tubing, or FMT, also known as greenfield, is a type of flexible conduit that is similar to FMC but is more lightweight and flexible. It is often used in tight spaces or where frequent bending is required. FMT is not suitable for wet locations unless it is specifically listed for that purpose. Fifthly, liquid-type flexible non-metallic conduit, or LFNC, is a non-metallic conduit that is liquid-tight and resistant to corrosion. It is commonly used in wet locations or where chemicals are present. LFNC is lightweight and easy to install, making it a good choice for a variety of applications. When installing flexible conduit, it's crucial to adhere to the NEC guidelines regarding bending radius, support intervals, and proper termination methods. The bending radius refers to the minimum radius to which the conduit can be bent without damaging it or the conductors inside. Exceeding the minimum bending radius can cause the conduit to kink or collapse, reducing its capacity and potentially damaging the wiring. Support intervals refer to the distance between supports that hold the conduit in place. The NEC specifies the maximum support intervals for different types and sizes of flexible conduit to prevent sagging or damage. Proper termination methods involve using the correct fittings and connectors to ensure a secure and reliable connection between the flexible conduit and the equipment it is connected to. The fittings must be listed for use with the specific type of flexible conduit being used, and they must be installed according to the manufacturer's instructions. In the context of generators and automatic transfer switches, the flexible conduit serves several important functions. Firstly, it provides a flexible connection between the generator and the transfer switch, allowing for slight movements or adjustments without stressing the wiring. This is particularly important during generator startup and shutdown, when vibrations can be significant. Secondly, it acts as a barrier against moisture and dust, protecting the conductors from environmental factors that could cause corrosion or electrical faults. This is especially important in outdoor installations or in environments where the generator and transfer switch are exposed to the elements. Thirdly, it helps to contain any potential arc flashes or electrical faults that may occur within the generator or transfer switch, reducing the risk of fire or injury. The metal conduit provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. The NEC contains specific requirements for grounding flexible conduit to ensure that it is properly bonded and grounded. This is essential for preventing electrical shock hazards and for providing a low impedance path for fault current to flow back to the source. Grounding can be achieved by using a separate grounding conductor or by using listed fittings that provide a grounding connection between the conduit and the equipment it is connected to. When selecting flexible conduit for generator and automatic transfer switch installations, it's important to consider the specific environmental conditions and the type of conductors being used. For example, in wet locations, liquid-tight flexible conduit is required to prevent water from entering the conduit and damaging the conductors. In areas where the conduit is exposed to chemicals or corrosive substances, a corrosion-resistant type of flexible conduit should be used. The size of the flexible conduit must also be appropriate for the size and number of conductors being installed. The NEC provides tables that specify the maximum number of conductors that can be installed in different sizes of conduit. It's important to consult these tables to ensure that the conduit is not overloaded, which could lead to overheating and electrical faults. Furthermore, the type of conductors being used can also affect the choice of flexible conduit. For example, if the conductors are insulated with a material that is not compatible with the flexible conduit, it could cause the insulation to degrade over time, leading to electrical faults. It's important to select conductors that are specifically listed for use with the type of flexible conduit being used. In addition to the NEC requirements, local codes and regulations may also apply to generator and automatic transfer switch installations. It's important to check with the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. This may involve obtaining permits, submitting plans, and undergoing inspections. Failure to comply with local codes and regulations can result in fines, delays, and even the shutdown of the installation. Proper installation of flexible conduit is crucial for ensuring the safety and reliability of generator and automatic transfer switch installations. This includes properly supporting the conduit, using the correct fittings and connectors, and grounding the conduit according to the NEC requirements. It's also important to protect the conduit from physical damage, such as impact or abrasion, which could compromise its integrity. Regular inspections and maintenance of flexible conduit are also essential for identifying and addressing any potential problems before they become serious. This includes checking for signs of damage, corrosion, or loose connections. Any damaged or worn conduit should be replaced immediately to prevent electrical faults or safety hazards. In summary, the NEC requires the use of flexible conduit for connecting generators and automatic transfer switches to provide flexibility, vibration dampening, and protection against environmental factors. Proper selection, installation, and maintenance of flexible conduit are essential for ensuring the safety and reliability of these installations. Always consult the NEC and local codes and regulations to ensure full compliance. In addition to the safety aspects, using flexible conduit also simplifies the installation and maintenance of generators and automatic transfer switches. The flexibility of the conduit allows for easier routing of the wiring, especially in tight spaces or around obstacles. This can save time and labor during the installation process. Furthermore, the flexible conduit makes it easier to access the wiring for maintenance or repairs. The conduit can be easily disconnected and moved out of the way, providing access to the conductors and connection points. This can reduce the time and effort required for maintenance tasks, minimizing downtime and improving overall system reliability. When connecting flexible conduit to generators and automatic transfer switches, it's important to use the correct type of fittings and connectors. The fittings must be listed for use with the specific type of flexible conduit being used, and they must be installed according to the manufacturer's instructions. Using the wrong type of fittings or installing them improperly can compromise the integrity of the connection, leading to electrical faults or safety hazards. There are several different types of fittings available for connecting flexible conduit, including compression fittings, set screw fittings, and snap-in fittings. Compression fittings provide a secure and reliable connection by compressing the conduit against the fitting body. Set screw fittings use set screws to secure the conduit to the fitting. Snap-in fittings are designed for quick and easy installation, allowing the conduit to be snapped into the fitting without the need for tools. The choice of fitting depends on the type of flexible conduit being used, the environmental conditions, and the specific application. In addition to the mechanical connection, the fittings must also provide a good electrical connection to ensure that the conduit is properly grounded. This can be achieved by using fittings that have a grounding lug or by using a separate grounding conductor that is connected to the fitting. The grounding connection must be properly sized and installed to provide a low impedance path for fault current to flow back to the source. It's also important to protect the flexible conduit from physical damage. The conduit should be routed in a way that minimizes the risk of impact or abrasion. If the conduit is exposed to physical damage, it should be protected by a guard or a barrier. The guard or barrier should be made of a durable material that can withstand the expected level of impact or abrasion. Furthermore, the flexible conduit should be inspected regularly for signs of damage such as cracks, dents, or corrosion. Any damage to a worn conduit should be replaced immediately to prevent electrical faults or safety hazards. In addition to the flexible conduit itself, the conductors inside the conduit must also be properly selected and installed. The conductors must be sized appropriately for the load they are carrying, and they must be insulated with a material that is compatible with the flexible conduit. The conductors should also be protected from physical damage, such as abrasion or bending. This can be achieved by using conductors that are specifically designed for use in flexible conduit or by using a protective sleeve or wrap around the conductors. The conductors should also be properly terminated at the connection points. The terminations must be clean and tight to ensure a good electrical connection. Loose or corroded terminations can cause overheating and electrical faults. In addition to the technical aspects of installing flexible conduit, it's also important to follow proper safety procedures. This includes wearing appropriate personal protective equipment, such as gloves and eye protection, and energizing the circuit before working on it. It's also important to use the correct tools and equipment for the job and to follow the manufacturer's instructions. Working with electricity can be dangerous, and it's important to take all necessary precautions to prevent accidents. When working with generators and automatic transfer switches, it's also important to be aware of the potential hazards associated with these devices. Generators can produce high voltages and currents, and automatic transfer switches can switch between different power sources, which can create unexpected voltage changes. It's important to follow all safety procedures and to be aware of the potential hazards to prevent accidents. In conclusion, the NEC requires the use of flexible conduit for connecting generators and automatic transfer switches to provide flexibility, vibration dampening, and protection against environmental factors. Proper selection, installation, and maintenance of flexible conduit are essential for ensuring the safety and reliability of these installations. Always consult the NEC and local codes and regulations to ensure full compliance.